Today's revision is on mathematical modelling. So you are going to go through 3 examples of constructing a mathematical model, modelling assumptions, and then looking at the quantities and units we use with mathematical modelling in mechanics. So the first question, we have a motion of a basketball as it leaves a player's hand and passes through the net can be modelled using the equation h equals 2 plus 1.1x subtract 0.1x squared, where h is the height of the basketball above the ground and x is that horizontal distance. So part A is asking us to find the height of the basketball, first of all, when it is released. So when this basketball is released, the horizontal distance is equal to 0. So our height, we've got 2 plus 1.1 times 0, subtract 0.1 multiplied by 0 squared, which is just equal to 2. Now here, I've just got an answer of 2. I've been asked to write down the height of the ball, therefore I need to give it in context, so the height is 2 metres. For part II, it says the height of the ball when we've got a horizontal distance of 0.5. So we're going to use the equation that we're given, the model of the height of the ball. That's h equals 2 plus 1.1 multiplied by 0.5, subtract 0.1 multiplied by 0.5 squared. Now if you type this into your calculator, you will get an answer of 2.525. So the height, I'm going to round this to 3 significant figures, is 2.53 metres. Part B to this question says use the model to predict the height of the basketball when it is at a horizontal distance of 15 metres from the player. So we're doing the exact same thing, but now x equals 15. So when x equals 15, h equals 2 plus 1.1 multiplied by 15, subtract 0.1 multiplied by 15 squared. Now this gives me an answer of minus 4, so the height is negative 4 metres. Now part C of this question says comment on the validity of this prediction. So just remembering that part B asked us to predict the height, and we've got a negative answer here. Now we know that a height above the ground cannot be negative, and we know that minus 4, so 4 metres below the ground, it's not really realistic for the basketball to then end up 4 metres underground. So we would say the height cannot be negative, so the model is not valid when x equals 15 metres. For guided practice 3, we are being asked to write quantities in SI units. So this is the International System of Units, and this is our modern form of the metric system. So SI units, we want our mass to be in kilograms, our length or displacement to be calculated in meters, and our time to be calculated in seconds. So these are our 3 SI units. For part A, we're asked to write 4 kilometres in our SI units. So we want to convert our kilometres into metres. Now we know that there are 1,000 metres in a kilometre, so we're doing 4 multiplied by 1,000 metres, which is 4,000 metres. For part B, we've got 0.3 0.32 grams. Now, to get from grams to kilograms, well, there's 1,000 grams in 1 kilogram. So to get from 1,000 to 1, we've divided by 1,000. So we're going to do 0.32 grams divided by 1,000, which is 0.0032. And if we were to write that in standard form, that is 3.2 multiplied by 10 to the power of minus 4 kilograms. Now the next question also includes standard form. So if this is what's confusing you, I'd suggest you go onto Haggerty Maths, type in standard form and do a bit of revision from GCSE. Part C, we've got 5.1 multiplied by 10 to the power of 6 kilometres per hour. Now this is a speed that's given in kilometres per hour. Now, looking at our SI units, if we want to measure speed, we want metres per second, because our distance, or displacement, sorry, is measured in metres, our time is measured in seconds, not kilometres, not hours. So this is equal to then 5.1 multiplied by 10 to the power of 6. To convert this into metres, we need to multiply that by 1,000. To get from kilometres to metres, we multiply by 1,000. So we've got 5.1 multiplied by 10 to the power of 9 metres per hour. Now to get from 1 hour to 1 second, we need to divide by 60 and divide by 60 again. That's because 1 hour is equal to 60 mins, which is equal to 60 times 60 seconds. So to get from 1 hour to seconds, we need to divide by 60 times 60. So 5.1 times 10 to the power of 9, that's our speed in metres per hour. We want to divide that by 60 times 60, going from hours to seconds. If I type this in my calculator, I get 1.42 times 10 to the power of 6 metres per second.